Hi, today I will go through some of the basics of Docker networking, and I will discuss how network isolation is achieved through tools like Weave, which are quite new. But before that, I'll just discuss very briefly the way Docker containers communicate with each other and with the outside world. So here is a very brief description of what happens. So this is a Docker host, uh, and as you can see, it has a NIC which is connected outside. Uh, this is a Linux box, and when you actually install Docker here, you get something called the Docker Zero, which is basically a bridge. By default, all the networking in Docker happens through this bridge. You have other options. You can have your custom bridge. You can also use host networking, but by default, the Docker containers communicate through this bridge. So the moment Docker gets installed, the NAT table in the host gets modified, and then you create your containers. So with the creation of containers, you also get the virtual interfaces, a pair of virtual interfaces. These are basically two ends of a pipe. One end goes to become the ETH0 for the Docker container, and the other end binds with um, the Docker Zero bridge. So similarly, when you have other containers, you also get their corresponding veth, and they communicate through this Docker Zero bridge. So when you have to communicate uh, between the containers, you send a packet, it goes through the bridge and comes to the other container. Similarly, if you have to send a packet outside, this is how the communication actually happens. So I have a Ubuntu host here. I'll just show what happens when you actually install Docker. So you can see if I do a um, so I have actually installed Docker here already, and with that, if you do a brctl, you can actually see Docker Zero. So it is already there. Um, so now I will, and there are no Docker containers right now here. So nothing at all. I have the Ubuntu image already downloaded here. So I'll go ahead and create some containers, and I'll actually show you what happens. So I'll do a Docker run. So I'll run this container. So um, there is a container now running here, and if you now do a brctl show, what you can see is in the interfaces there is already a virtual Ethernet interface. So this was created when you actually created the Docker container. So our Docker container ID is this, and the name is this. So I'll go ahead and create a second container, and we'll see how the communication between them happens. So here is my second container. So I should have two containers now. So this is the first container and this is the second container. Now I will go into the container. I will actually go inside the container. So I'm going inside the first container, and on a different terminal, I'll go inside the second container. So as you can see, the second container has got an IP of 172.17.0.5. Now coming back to the first terminal, I will also see, and you can see that it has got an IP of 172.17.0.4. So what I'll do is I'll now ping the second container from the first container. As you can see, the second container is actually reachable. So within a host, uh, the containers can talk to each other like this. Uh, the Docker 0 bridge actually shares an IP which is 172.17.0.1. So all the subsequent containers get IPs in this subnet, and hence they can talk to each other. But if you want the containers to not talk to each other, there is a way of doing it. Before that, I will actually show you what happens when you what happens to the IP tables when uh, the containers are in existence. So I have come back to the host, and if I do a, you can see everything is basically accepted. So and in the meantime, if you want to see uh, the NAT table, you can actually see the masquerading happening here. So basically, the uh, every packet which is going outside from the container, from the Docker container, is actually masqueraded and sent out. Now, if we want basically some kind of isolation for the containers, we don't want the container to talk to each other. We can actually do something. We can actually go to a file. I'll just take down that thing, and we have to basically uh, go to by the way, this location changes as per your operating system. Also in Ubuntu, it is etc default Docker. So I go to etc default Docker, and then I actually put the Docker ops here. What it means is uh, uh, I'm basically telling the I'm basically telling that the Docker container, when it comes up, it will actually it can change the IP tables, and then I'm not allowing them to talk to each other. So basically, the packets coming from any Docker container after this is implemented will be dropped. So let's see what happens. We have already seen that the Docker containers can actually talk to each other. So I will have to I'll have to basically restart the Docker service to for this to take effect. So I'll do a service Docker restart. So let's see what happens. So it got restarted, and now if I see the, so you can see that now there is a drop. So now let's see how the Docker communication happens, or is it allowed. So I will actually go ahead and create two containers once again. So I'm creating the first container. I'm creating the second container. Done. So by the way, you are not able to see the earlier containers because the Docker service got restarted. They are here most probably. Sorry, that should be all. Yeah, so you can see the containers are there, not just that they were actually shut down. So I could have restarted them. I just restarted. I just created two more containers, and now I'll go inside the first one. So I'm sorry. I'm inside the first container, and now I'll go inside the second one. So you can see the IP which the second container got is this, and I come back to the first container. I try to ping it. It's not pingable. So basically, I have created an isolation. This facility is by default, so you can actually restrict your uh, containers from talking to each other. So by default, Docker doesn't allow any inward connection from the outside world. Uh, the way it actually accepts any connection from the outside world is by mapping one of its port to the host. So I'll just show how it is actually done. So I will run a Docker container here. So I'll just say that the container would actually map its one of its port to the one port of the host. So let the port host be the host of the port. The port of the host, sorry, should let it be 3434, and on the container, uh, let it be 2222, and then I'll just run this container. So done. So you can see that the port mapping is already shown here. Um, you could have also done a Docker port and the container ID. This should also most probably show that how the port mapping is actually done. So now I'll actually go inside the container and see how the communication actually happens. So I will do a Docker attach. I'll go inside the container. I'm inside. So I will actually run a netcat, and I'll listen on the port 2222. So I'm listening, and remember my host is a Ubuntu VM. So I will actually go outside the VM and try to connect to the host on this port. So I am outside the VM now. Um, and I'll do a echo. I'll pass it to NC. Let's see, just see the option. Host 3, and I think it was 3434. I'm sorry. So as you can see, it has come here. So I actually communicated to the 3434 port. I can do it once again, and I can do it repeatedly just to make sure that you understand. Um, so we are seeing that there is a communication between the two, the container and the outside world. So it is done through port mapping. Now I will demonstrate and briefly explain how Weave works. This diagram is directly from their website. So Weave actually helps you communicate between containers which are deployed across different hosts. It can be uh, hosts which are placed in different data centers. So as you can see, it actually creates something called the Weave router, and the Weave router actually talks to each other, talks to themselves. So these are three hosts, and they have their own Docker containers running, and the Weave router is actually creating a router to communicate between themselves. So I found it quite simple to use and understand also, and it provides very basic network isolation. I do not have much experience with the stability of Weave, but I have been using it for now almost a week, and it's quite basic, but it provides you what it actually promises. So let's go and see what Weave can do. So I have actually three hosts here: host 1, host 2, and host 3. I have installed Weave in all three of them, and host 2 and host 1 are actually uh, communicating with each other. So I'll show in host 3 how it is done. So I'll not go into the Weave install. It's quite simple. Um, so I have Weave here. I have it, but it's not connected to the already formed cluster. So Weave also actually gives you the facility of connecting, dynamically connecting Docker containers, and that's what we are going to show here. So I'll show what the other um, so this is my host 2, this is my host 1, and what I'm going to do is I'm going to do something called Weave status. So Weave status actually shows that there are two hosts in this particular cluster right now. So and these are the IPs. So similarly, if I go to my host 2 and if I do a Weave status, I get the very same thing. Now I come to host 3. Here I have not actually launched Weave yet. So if I do a weave status, I don't get anything. So let us launch weave launch, and then I'll give host 1. So by the way, the etc hosts file in host 3 has the information about host 1, which is why I could directly use host 1. So let's see what happens. So as you can see, something happened. I think we've got launched. So now you can see that, so the IP of, so maybe I'll just show it here. So this is again host 3. So the IP address of host 3 is 26, and if you can see here, so 26 got added. We can go to host 1 and find the same thing. So you can see that exactly same result is being shown here also, and you can see 26 got added here. So now the containers are which are actually attached to Weave in host 1, host 2, and host 3, if they are put under similar subnets, they can actually talk to each other, and that's what I'm going to show now. So in host 1, I already have some containers which are actually have been put in some kind of a network. So as you can see, this particular container is in this network. This is in host 1. So maybe I'll just detach these just to make sure that it's a little easier to understand. So this is my host 1. Let me go back. This is my host 2. And this is my host 3. So as I said, Weave is running in all 3 of them. So this is host 1, host 2, and host 3. So let me do a Weave PS on host 2, and as you can see that this particular container is in 10.2.20.1. This is the IP address of the container, and in host 2 I have another container, in fact 2 containers, which are in the same network. So let me go ahead and go inside the container here. So docker attach this one here. I'm inside, and let me try to ping this particular one. So as you can see, it is reachable. Similarly, I could actually go to this container here. I'll go to this one, 10.2.0.2. Sorry. it should be Docker. So I'm inside 10.2.0.2, and I will actually try to ping a container which is in the same network. So as you can see, this container is in the same network and it has been given an IP of 10.2.0.1 by Weave. So from inside this, I'll just ping. Did I do a mistake here? I actually got attached to a D. Okay, I think this is not yet connected. So let me try to actually connect a new container to Weave and see how it behaves. So anyway, we saw that two containers which are actually connected to Weave and has IPs of 10.2.20.1 and 10.2.20.3 could actually communicate with each other. So I'll go here. I already have a uh, container here, um, this one which I created just a few minutes back, this one, and I will actually try to attach it to Weave. So let us see how the Weave command is. So I will do a Weave attach. So I'll do a Weave attach. I have to give the CIDR. So let me give it a CIDR of this. Let me give it 5/24 and the container ID. So I'm attaching this container, um, Sharp Bartik. This is the container name, and let's see how it goes. So I have attached. Let's see if yeah, it shows that WeavePS actually shows that there is a container with IP this, and if I now go inside this, doing a Docker attach, I should be able to ping anything in the network, in this network. So let me try to ping this. I don't know. Yeah, it is reachable. So so you can see that now with Weave, uh, we could actually establish a connection between containers which are actually lying on different hosts. Uh, and now what I'll try to do is I will, but still from the host itself, so my host cannot yet um, reach out to this subnet which I have created through Weave. So to do that, what I can do is I can do something called Weave expose. So I will just expose an IP in this subnet. Um, let me do it like yeah, anything will actually go. So so what will happen is the host will now have an IP of 10.2.20.198 and when it is done, so now I don't have to go inside a container. So previously what I was doing is I was going inside this container to access anything in this subnet. Now I should be able to actually ping, first of all, this directly. I am able to ping, and then I'll try to ping um, um, this one dot one. So you can see I could actually ping a container which is in host 1 from the host 3 directly. And this could be actually across data centers. This could be um, in different hosts across data centers. So this is how basically Weave approaches the network isolation problem. Very basic, um, but it is quite simple to understand, and you could actually start using it right away. If you are comfortable with Docker, the installation process is quite simple, and it gives you an opportunity. So by the way, the Docker properties. So I have now the um, the container is now attached to Weave. So if I do a Docker PS, I see that I'll just clear it. I see that uh, how the ports were actually mapped. It is still valid. So this container will actually continue to listen. Will actually have its port 2222 mapped to host 3's 3434. So Weave doesn't affect that communication. So if somebody is trying to reach out to the container from outside, they could actually reach out to the port, this particular port of host 3 to which the container's port is actually mapped, and then they could actually talk to the container. So this was a very short and brief demonstration about Weave. Hopefully it was useful.